Hello. So in this video we have a simple displacement time graph. So that's a graph that shows displacement and also shows time. So we're going to look at how we can use them and just a simple introduction to how they work. So we have a time axis on the x-axis. That's the x-axis right there. And then on the y-axis it's displacement. So let's have an example just to see exactly how this would work. So maybe let's start out with someone at 0, that's 0. So 0 time and 0 displacement. Maybe we're measuring the displacement of a girl from her home, and that's her home right there. And it's the girl, and she's going to be moving away from her home. Let's say for the first few seconds, for the first 5 seconds, she covers a distance of 2 meters. So in 5 seconds, she covers a distance of, let's increase that to 20 meters. Then she keeps walking another 5 seconds, she covers the same distance. So she covers, now it's now 10 seconds, and now she's covered another 20, so 40. So let's look at what this would mean. So in the first 5 seconds, she covered 20 meters. So 20 meters in 5 seconds, so maybe she's somewhere there. So she's now 20 meters. Then another 5 seconds passed, and she moved even further. It's now 10 seconds, and she's now 40 whole meters away. Then let's say she stops somewhere, maybe at the bus stop, somewhere at the bus stop, yeah, and she stays there for 5 seconds, so she's not moving. So if you're not moving, you're not going to be moving any further away. So if you are 40 meters away from your home and you stop moving, you're going to stay 40 meters away from your home. So this shows that basically maybe she stays there for 10 seconds. So at 15, she's still 40 meters away from home because she's not moving. At time 20, she's still also 40 meters away from home because she's still not moving. Then maybe now the bus comes along. So now we have a bus. The bus has come along. So we put the bus and another 5 seconds pass. So time 25, she gets on the bus at time 20 after spending all this time not moving at all. That's why her displacement was still 40. So for this time, in 5 seconds, instead of only moving 20 meters, this time let's say she goes all the way there, all the way up to there. So she goes 40, 60, 80. So she gets from 40 all the way to 80. So she covers 40 meters in how many seconds? Let's think about it. 5 seconds. 5 seconds. So this makes sense because while she was walking, she was only covering a shorter distance. What do you see is different? It seems that the graph here is steeper where she's moving in a bus and she has higher speed. So actually that makes sense because when you have a displacement time graph, the steeper the graph is, the higher the speed of the person is. Or we can think about it as saying the gradient of this graph, the gradient of the displacement graph, so the slope or how steep this is, shows the speed of the object. And this makes sense because you get gradient by dividing the change in y, or delta y, divided by delta x. Change in y over change in x. Change in y will be in meters and change in the x-axis will be seconds, and meters per second is the unit for speed. So how steep this is shows the speed. So you can see when she was not moving, when her speed was 0, the gradient is 0. She's not moving. But in addition, she doesn't have to just walk forward. She can stop right there. Maybe she reaches her destination, stays there for another 5 seconds. Now it's time 30. Then at time 30, she gets in a van, maybe, and then she drives all the way back home. And let's see what that would work. So if she drove all the way back home, what would be her displacement when she's back home? Remember, displacement, we're measuring where you are and where you ended. So if she started from home and she ended at home, that's 0 displacement because she's come back to the same place. So when she comes back to the same place, she should end back at home. So she should end back somewhere there at 0 displacement. So this time the graph will look like that. She's driving, she's going back home. That is why we can see that the graph ends at the displacement 0 when she's back home. And that is the idea of displacement time graphs. We can also look at the gradient of this to think more about it. If you look at the gradient here, here, and here, the gradient here is positive because it's sloping in that direction, like that and like that, while the gradient here, the gradient there, is negative. The gradient here is negative, right here. Let me just put in a different color. The gradient there is negative. right there. Sorry. Right, that's a zero gradient, and that's the negative gradient right there. That's negative gradient. It's negative gradient. Let's just get that back. The pink gradient is negative because it's sloping in that direction, and we can see that when she's coming back home on this way back, that's when the gradient is negative, when she's going back home, back to zero displacement. So actually that shows if the gradient is negative, she's traveling in the opposite direction. So here she's going forwards, and then backwards. That's the introduction to displacement time graphs.